Hi, my name is Dwight Stevenson, and I'm applying for the Desmos Fellowship. So this video is to show you my favorite part about Desmos and just kind of, I guess, teach you what I'm doing right now. So this is centered around the post that you guys created, which asks the question, when a wheel that rotates along a parabola, when a wheel rotates around a parabola, does the center of the wheel also follow the path of a parabola? And I've been thinking about this a lot today, and as you can see, I already replied once. And I was trying to. So here's my graph, right? I've been trying to create, um, and I've had some extra stuff here because we're gonna do this. But I've been trying to create the parabola, and I think I've got the parabola that and the wheel can follow it along, right? You can see mine's going a different direction. That purple line is the perpendicular, the normal line, right? Which was necessary to create it so that the circle would only touch at that point, right? And we can change a lot about this. We can change the radius, make that circle bigger or smaller. And if we go on this side, you can see I have the center of the circle in there. The center of the circle is defined, right? I can find any point on that curve that the center circles, but I've been having trouble writing an equation for the actual curve, right? So I almost have it as like a parametric thing where it's defined in terms of another variable, where the variable here is like this b, which maybe like a better variable would be like t or something like that, right? This 1 over 2a is actually the derivative, right? Because it's the slope at that point, which is what I used down here when I defined it for b less than 0. So what I'm going to try to do right now is I looked up parabolas to see if there's anything that would help me do this, and I discovered this 4-point property of a parabola, which basically, if you see the diagram, if we construct this, then these two red lines should be parallel if they're parabola, if it's a parabola, right? So that's what I'm going to try to show. Is I'm going to try to create those 4 points, make them movable so we can change it as we go, and then see if those two red lines will be parallel when we do this. And I created one video where I just looked at the I just simply looked at the x and y coordinates and used those as my points to create the lines. But I kind of want to create something that moves a little bit more. So what I'm going to do is I'm going to build this here. I've already created 4 sliders. I'm going to make 4 points where these sliders are simply going to move me a little bit away from where the center currently is, right? These will still be on the path that the center's tracing, but they'll be shifted in one of the directions, one way or the other way, right? So let me see if I can find point D. So here's point D, right? D is just going to be a little bit farther off. Sorry, this is point P1. And I'm going to go ahead and copy this and make P2. But for P2, I'm going to use the slider for T. The reason I'm using the slider is just so we can move it around and make sure that it applies in a more general case, right? Not just in one specific case. So I'm going to change all these guys to T's instead. And we'll change T to something. So here's T. It's over here. And what's important for us to understand is that these 2 points that I've created so far, they lie on the parabola, right? Like they're on, or sorry, it might not be a parabola, right? But they lie on the curve that this center is tracing, right? If I move my, if I move my B around, it would pass through these points that are on there. It won't show that because these points are actually going to move with B, but like all I'm doing is moving it one way or the other, so it will go through there. Let's go ahead and put the rest of the points on here. We're going to use U for this one. And U, I want this one to be on the other side, so I actually need to change this a little bit. I need to make this a negative. Actually, here, let me do this. So I created one equation for the circle when b is greater than 0, and I created another one when b was less than 0. The only difference here is there's a negative sign in front of this one. But it does change things. So I'm going to go ahead and use this one for the rest of the points. Oh, I need to call this one something else. Did I call this one something else? Right, this should be called P2. Let's call that one P2. So then we're going to make P3, which is going to equal, this is going to be the x coordinate, but we're going to add u in here, and we're going to add u in here. And so what I'm trying to demonstrate with this is, the thing I really like about Desmos is the ability to experiment with things and just try something and see if it works. And you get like instant feedback about whether the thing you're doing is actually working or not, right? Which is so cool. And like, there's no way I'd ever do this advanced of math, you know, if I wasn't able to like see it like this, right? Because it would be way too hard. So like already what I can see is like this point's showing up right there, which that's not where that should be showing up. So I'm trying to figure out, you know, what did I do wrong with this? The u, right? That is definitely not what I want, right? So what's going on? Right here, we have to add the u there, and I was adding d over here, which of course, right? So you just instantly can see the mistakes you're making as you make them and fix them. Still a mistake somewhere, right? Because that does not look correct. So let's see. All right. I don't see the mistake. The only difference that's going on in this one is I used the actual derivative down here instead of the 2a. Let me see if I can change this real quick. 2a. It shouldn't make a difference, but there's something wrong. B plus u and f of b plus u. It really shouldn't make a difference. F prime x. Oh, that's why, because we're using x3 there. So I actually need to use, how did I define this? I was using x1. Okay, I'm going to pause the thing and see if I can fix this. Not on the video, so you don't have to watch me do this. So I found the mistake. I was using, even in these other ones, it was messed up, and you probably caught it before I did, but I was using x1 here for this, but when I defined x1, I didn't put in the transformation for the b's in x1, so it wasn't properly transforming it, and this one just happened to show up a little bit more obviously. So I actually need to take this guy, and we're using u, and I was using x3 before, right? But I can't use x3 because that doesn't have the transformation in it, so I need to use that like such. It still looks a little bit off. I think all these just go away, right? I don't need all this mess. Those just cancel out with each other, so say goodbye, all those. It looks too far out, doesn't it? That doesn't look like it should work. Let's, if I move it over. Ooh, what's going on there? Look at that. That red dot's following really well, but look at that orange dot. That orange dot is not following me right. What is it doing? Right, when I move my B, those things should not be doing that. So what's wrong with you, orange? Let's see. Oh, the red dot's good, right? Let's look at this red dot, right? It's doing what it should be doing, right? It's not doing anything funky until we get to there. Huh. Well, I thought this was going to work, but it looks like it's gets a little funky at certain points. I look how those things are moving around over there. I thought I had it defined so it would just be like a future point almost, right? It would just be defined in the future, like a little bit ahead of where it currently is. But that doesn't seem to be doing it. So, let's think. I'm gonna think about this some more. I'll come back to you. Okay, I think I got it. I had not put a b plus d right here, right? So I didn't put the transformation on all the places where that b is, and that's what messed that up. Okay, so these points work over here, I believe, right? I could still be wrong, and we'll see how this works out. And then point 3 over here, we're using u, and I have all those in there correctly. So let's move our b over here and see if I got that fixed. Oops, not d. Let's move our b over here. Now, the orange and the red one are going to get messed up because they're not defined over here. I'm just interested in if this one is good or not, the one with the U. Let's get him a little bit closer and see if he looks like he's following the correct path. It looks like it is to me, right? It looks like I've defined it correctly. It's like a future point for what the radius will look like. On the left-hand side, I had to define two separate ones, one positive, one negative. All right, so now we're going to do one more point here, and the variable we're using now is j. So I need to replace all these u's with j's. And we'll see. So j right now is 1, which means it's going to be like a past point, while the other one was negative. Let's see what this looks like. Oops, I don't want to move that one. I move b. Let's see if it's a past point, right? Like a point in the past for this. Looks like it's working. All right, so what we need to do is, somehow we need to have all these points at the same time, right? So, there, if I just have to make these ones bigger, right, and put them over here. Cool. Well, let's go ahead and label them. That might help a little bit. Okay, so we're done creating the points. So I'm going to turn off my, let's turn off my circle. Yeah, that's right. So basically what we're going to do is we're going to connect the black one and one of the red ones. Let's make them color coordinated. So I'm going to change the black one and this black one, and I'm going to connect this red one, these two orange ones together, and then we also connect this black one with this orange one, and then we create I connect this orange one with this black one, and I create the perpendicular lines that go down from this one and this one, and then we find out where those secant lines intersect those perpendicular lines to the x-axis, and we draw the line through those points of intersection. And if the resulting two lines that we get there are parallel, then we're good. So that's what we're doing now. We're gonna connect the black lines, and we're gonna connect the black lines. Oh, so this is P3. Oh, that's cool. I can label these guys. I didn't know that. So that's not P3. This one should be called P4. So let's see how they label it. We'll get it the same way. P1 on the left. Ooh, yeah, no, we're not going to do that. This one's P4. This one is P3. This one is P2. And this is P1. So we're connecting P1 and P3 and P2 and P4. That's how we're going to do it. So we got to draw, but not draw. We don't get to draw on Desmos. We don't have to draw. We get to create equations for it. So I need to connect those two lines, or those 2 points, which means I need the equational line, y minus y1 equals m x minus x1. It's going to be a bit complex because I have to use the x and the y coordinates from each of my points, right? So we're trying to connect the orange point. So let's first grab the orange y coordinate, which is that whole mess, and put it right there. And then we need the x coordinate for that same point. So we're going to grab this, and we're going to put it on the x over here. And then we need a slope, which means we need to take the y coordinates from the 2 points. Let's start with this one since it's closer. I'm going to take this y coordinate, put it here, and subtract the y coordinate of this one. I feel like this would have been easier if I would have just given them names instead of trying to write them all out like this, but I've already started, so this is where I am. All right, that's that. That's y minus y1 equals, I'm trying to do a slope. We don't need this for the slope. I'm not sure why that got copied. We don't need that for the slope. We just need, all right, let me start over on this piece because that looks a little bit messed up. So I just need from here to there. That's all I need. That goes here. Minus, and I just need this piece to there. So take that and put it in here. And then we get the x coordinates down here. So we take this x coordinate, and we subtract this one. And we should see a line pop up out of this whole mess. Oh no, instantaneous feedback, right? My line is not correct. So what did I do wrong? You're probably getting bored watching this, so I am going to do it and then show you the final result. Okay, checking in, I was able to get the 2 lines that cross through like such, and the issue before was just a missing parenthesis somewhere. So, you know, I'm making progress towards it. You know, it's been a few minutes, but remember, this is like these a parabola here. The next thing for me to do is connect P4 and P1 and create 2 vertical lines that extend down from P3 and extend down from P2. So when I come back, I'll have done that. Okay, so I've made some progress. I've connected all the necessary lines, right? The last thing I need to do is connect Q1 with Q2. And this is the part where, so let's remember, I have to imagine that there's the parabola that goes through this, right? There's a parabola connecting these. This red line here is the red line on this one that goes through P3 and P4. And what we need to check is that the line through Q1 and Q2 parallel to this one. So Q1 is going to occur right here, and Q2 is going to occur right there. Now what I'm trying to figure out is how am I going to write this so that it will change as my graph changes, right? How am I going to get this? So it's obviously the point of intersection between those 2 lines, right? So it's when the x coordinate of that blue line that goes through P2 and P4 is equal to the x-coordinate of P3. So somehow I have to work that out, all right? So basically, if I plug in the x-coordinate of P3 into P2, that's what I need to do, right? So I'm going to do that, and then write the equation of the line for it in there. And then we're going to try to see if they're parallel, right? And that's going to be the fun part. So on we go. Okay, so it seemed way too complicated to try to find this point. So this is what I did. I came up to the equation of the line through P2 and P4, and instead of just, you know, I called it Q of X, and what that allowed me to do in Desmos was down here, I know I wanted to have the same X coordinate as P3 does, so that this is the X coordinate of P3, and then this here is the function evaluated at that X coordinate, where the Q function is that line right there, right? So I'm going to do the same thing to find this point, right? I'm going to define this green line as a function instead, right? So instead of calling it Y, let's call it, I wonder if I can name it Q, I don't know, Q2 of X. So let me do that. Equals, if I move this whole thing over, it becomes positive, and then this needs to change to a plus sign. Okay, so it did let me do that. Right, so it's the same thing there, and then we're going to basically create a new point. Q2 is going to equal the x coordinate of the point 2, right? So we're going to take the x coordinate of point 2, I'm going to put it down here, and then we're going to evaluate Q sub 2 of that whole chunk, and notice that it gave us that point right here, which is so cool. So now we're going to try to draw the line through there and see if it's parallel, right? So I will do that and be right back. Okay, so successfully created this one. I want to turn this one red, right? So we've successfully created this situation on here. And so now the question is, are the red lines parallel, right? Is the line P3, P4 parallel to Q1, Q2, right? Where, let's go ahead and label these. This is Q1, and this is Q2, right? Are these going to be parallel? Now, there's probably some crazy algebraic way to do it, which we could do. But a cool thing about Desmos, again, is we can just go way out here, and we can notice that we can see they're definitely not parallel, right? In fact, they're going to cross right there at 47, 21. All right, so let's come back here and see what's cool about this is, you know, those were 4 points like that, but I can come up here and adjust which points are being used, right? So I can move that over there, move that up like that, and I can move these and change it to be pretty much any point on that parabola, and try to notice, like, are there values where it will be the same? Well, no matter what, I believe that it's not going to be a parabola, right? Like, this one is definitely not as obvious that it's not parallel, but I think if we go far enough this direction, we'll see that these lines do end up touching. Let's see if we can get there. A proof by exhaustion. Here I go. I'm going the wrong direction. I think I need to go the other direction. It seems like it's getting wider this way. Yeah, there we go. Skinny, skinny, skinny. Not parallel, right? So let's move them around a little bit more and see. I don't know, let's just pick some different numbers. Find it, and you see this one for sure is not parallel, right? You can tell automatically. So I think, and if you think I'm wrong, please tell me, because I'd love to be proven wrong on this. I think that we can say definitively that it is not a parabola, right? These 4 points lie on that parabola somehow. Not the Q ones, the P. The P's lie on a parabola. And they do not pass the test. So hope this, I know it wasn't the most exciting thing, but it was exciting to me. I was having a lot of fun. And I think that's how students are too, is you just get to try things, you get to play around, and it's, math becomes play. And you end up learning a lot. Like I learned a ton just doing this. And I know my students have as well when they've created, their graphs and stuff like that. So, yeah, thank you. And thanks for doing Desmos. I always get really excited about it, as do my students.